Math is the study of fictional objects and patterns with logical properties. Sometimes, simplification of a real-life problem results in a new mathematical object, and then a new branch of mathematics is born. For example, let's consider the historical problem of the 7 bridges of Königsberg. Königsberg was a city in Prussia that was divided in half by a river and included 2 large islands, all connected by 7 bridges. The problem was to visit each part of town while taking every bridge only once. Now, testing and trying different routes suggests that the problem is impossible. There always seems to be one bridge left over that you can't get to without retracing a bridge you already traveled on. But how can you prove this mathematically? This is where the famous mathematician Leonhard Euler comes in. First, he simplified the problem into an abstract concept. Mainlands turned into what are now called vertices. Bridges turned into what are now called edges. The resulting mathematical structure is called a graph, not to be confused with graphs of functions and charts. Then, he realized that in order for you to visit a vertex, you need an edge going into the vertex and an edge going out of the vertex, unless it's the start or end of your journey, in which case you only need one edge going in and out of the vertex. The number of edges connected to a vertex is called the vertice's degree. Therefore, to be able to traverse a graph visiting each edge only once, all the vertices need to have an even degree, except for the endpoints of the journey, which can be even or odd. Now, returning to our original graph, you can see that all the vertices have an odd degree. Since every vertex can't be an endpoint, it's impossible to traverse the graph while taking every edge only once. Graphs are an important mathematical structure that have many applications. For another example, let's consider the internet. Each web page can be thought of as a vertex, and each link from one web to another is an edge. This gigantic graph is a directed graph. Each of the edges have a direction. Here's an idea. Let the importance of a web page be defined by how many links point to it. Also, let links from important sites be worth more than links from less significant sites. This idea forms the basis for Google's PageRank algorithm. This is one of the most important algorithms that Google uses to handle more than 1 billion requests daily, letting users find pages that have the most relevant information. And this is all thanks to the power of math.